Hi friends, in this class we are discussing about integration. So integration is the reverse process of differentiation. So by integration we mean reversing the process of differentiation and finding the original function. For example, d by dx of f of x is usually known as f dash of x. Here we have to find this one from the value of f dash of x. So for simplicity, we give f dash of x as f of x. So by integration, this is the integral sign, integration, indefinite integral, that is f of x dx is equal to f of x plus c. Here what we have, integral sign, and this f of x is called integrand, and it means that indefinite integral with respect to x. This is called f of x dx is called indefinite integral with respect to x, and here is the result and c is the constant. So friends, let us see the rules of integration. So let's see the first rule, rule number 1. The integral of a constant k is integration. So it is indefinite integral, integration k dx is equal to kx plus c. So let us see an example. Integral phi dx. We have phi is constant. So by first rule we will be getting phi x plus c. So I have already told you that it is a reverse process of differentiation. So if you have any doubt, you just do differentiation d by dx of phi x plus c equal to what happens? It's a constant, and this one becomes 0 and phi. And the second rule is the integral of 1 written simply as dx, not 1 dx, okay? And integral dx is equal to x plus c. So we have 1 is already here and we are not writing it. So if we have let's do it. For example, there was d by dx of x plus c. What happens? d by dx by dx, okay, is equal to 1, and the constant becomes 0, so the answer is 1. That means there is already 1 and we are not writing it. So the third rule is integral of a power function x raised to n where n not equal to minus 1, and we will discuss this case later, is given by the power rule, that is integral x raised to n dx. Power rule, so x raised to n dx is equal to 1 by n plus 1 and x raised to n plus 1. So we have to add n plus 1 here and also here, okay, in both the numerator and the denominator. That's it. So since it is an indefinite integral, we always have to add the constant c here, okay, and where n not equal to minus 1. Let's see one example. Example x raised to phi, okay, that is integral x raised to phi dx is equal to 1 by n is phi, so phi plus 1 and x raised to phi plus 1 plus c, that is x raised to 6 by 6 plus c. And let's see one more example. Example 3x raised to 2. That is integral 2x raised to 0 to 1 by there is 3 is already there, so 1 by 2 plus 1 x raised to 2 plus 1 plus 3. So we have 3 by 3 x raised to 3 plus 3, that is x raised to 3 plus 3. And if you have any doubt, let us check it. For example, let's see the dx. So is plus c equal to what is the frequency by the product rule we will be getting x raised to 3 x raised to 3 is equal to 3. So this is the by the fourth rule, the integral of x raised to minus 1, we can write it as 1 by x whole, and 1 by x is integral x raised to minus 1 dx is equal to log x plus c, where x greater than 0. And the condition x greater than 0 is added because only positive numbers have logarithms. Okay, but if it is a negative number, and it becomes integral x raised to minus 1 dx modulus of logarithm of modulus of x plus c over x not equal to 0. Okay, this is the fourth rule. So let us see the fifth rule. The integral of an exponential function is integration a raised to kx dx. So it is an exponential function. So we have to take the numerator also as a raised to kx, but in the denominator we have a ln a plus c. So it is an integral of an exponential function. So the sixth rule is the integral of a natural exponential function, that is e raised to. So integral e raised to kx dx is equal to e raised to kx by a plus c, and since ln is equal to 1, so by the fifth rule we have to add a ln e, but ln e is equal to 1, and so we have only e raised to kx by k plus c. So let's see the seventh rule. That is rule 7. The integral of a constant. So here we are taking constant as a. The constant times the function equals the constant times the integral of the function. It's very simple. That is integral constant f of x, constant times f of x dx. So we are taking the constant outside. So that is k integral f of x dx. So let's see the eighth rule. The integral of sum or difference of two or more functions. So we are taking two functions as f of x and g of x here. Two functions equal to sum or difference of their integrals. That is integral f of x plus or minus g of x dx. There are two functions f of x and g of x. It is equal to integral. The separate integral we have to take. That is integral f of x dx plus or minus f of x integral g of x dx. So let's say the ninth rule. The integral of the negative of a function equals the negative of the integral of that function. It's very simple. That is integral of negative of a function is a negative function. So we have to take negative also. That is as we have taken the constant outside. That's all. And my integral negative f of x dx is equal to integral negative integral f of x dx. I hope that the rules are clear for you. If you have any doubt, please write in the comment box. Enjoy life.